Hello everyone, in this video I'm going to show you how to create your own VPC with public and private subnets. So in order to get started, go into the VPC section of the AWS console. You can go to the top here and just type in VPC, and we're going to click on that. And you're going to want to go to your VPCs over here on the side. Now, before we get into the tutorial, just one thing to keep in mind that by default, you get an AWS default VPC in every region in your AWS account. And with that comes a couple subnets as well for every availability zone. So you have some subnets here. This is one for each availability zone. So for most folks, just using this default subnet will work fine. But oftentimes folks want to create their own, either to set their own IP address space or for other reasons, or just start from scratch to learn all the concepts. So let me show you how to do this now to create our own. So first of all, just go to the top right under the VPC section and click on Create VPC. And recently, AWS has made their console experience a whole lot better. Previously, you only had this option here to create the VPC only and have to fill out a bunch of the different details here. But now they allow you to create your VPC, your subnets, your route tables, all that stuff all in one shot without having to go to different sections of the AWS console. And to do that, all you need to do is click on VPC and more. And this gives you a really nice wizard that you should be able to see here that lets you just use the UI to define the parameters of your VPC. So let's set this up together. So the first thing we need to decide is the name of our project. So let's just call this my VPC. Then we need to decide on an IPv4 CIDR block. Now the CIDR block is the network address space that is going to be used for private IP addresses in this VPC. Now by default, they'll give you 10.0.0.0/16. What that means is that these two places, the last two chunks of the IP address are flexible. They can be anything from 0 to 255. And then similarly, the last one could be anything from 0 to 255. So you can have 10.0.1.0, 10.0.2.0, 10.0.3.0, so on and so forth. And then this 0 can also go all the way up to 255. So this is a very liberal IPv4 CIDR block. As you can see here, it gives you a preview. This will give you access to over 65,000 IP addresses. I would actually change this to something a little bit different, like maybe .15 or .100 or something like that. And the reason is because if everyone is using default and the default is 10.0.0.0/16, and you need to set up VPC peering one day with maybe a different network, if everyone's using default, this may be a problem, right? You can't have overlapping IPv4 CIDR blocks. But anyways, you can pick a CIDR block that you're comfortable with and that it has the right number of IPs for your network. For IPv6, we're not going to be using that in this example just because it makes things a little bit more complicated, requires some slightly different setup. There's this concept of tenancy here. You can read all about it. If you want dedicated hardware for your VPC all on the same machine, you can request that using this tenancy model here. And here's where it gets a little bit interesting. You get to select the number of availability zones. So as you can see in the diagram over here, we have two chunks here for availability zones. We have both of these two are 1A and these two are 1B, as you can see with the naming here. So if we change this to one availability zone, we just get access to 1A. And if you change this to 3, you're going to get 3 different ones. Now, the reason you may want multiple availability zones or more than one, or even actually up to 6 is allowed in US East 1. This is different per region, by the way. The reason you may want to have a couple or more is because this is all about resiliency of your application. You can place your, for example, web app backend REST APIs on EC2 machines in different availability zones. So if one ever goes down due to some kind of power failure or some kind of natural disaster or something like that, your application could still remain up because traffic is being served from the other two still available availability zones. So in this case, I'm just going to leave this as 2 just so it doesn't get a little bit too overwhelming here. And then from there as well, you get to specify the number of public subnets that you want. Now with this wizard, as you crank up the number of availability zones, you also crank up the number of subnets, both public and private, that become available to you. So just keep that in mind as well. We're going to leave this as 2 just so we can get a little bit of breadth of different subnets in this demonstration. And then you can also customize this as well. So if you want these to be in different availability zones, like maybe you like 1C over 1A, then you can totally do that. Keep in mind that these are different from account to account. So your 1A is one physical location and my 1A can be a different physical location. So 1A doesn't mean the same for everyone. This is just something that they do so that everyone doesn't end up picking 1A. Anyways, that's a different topic. So for public subnets, we'll leave that as 2. For private subnets, we'll also leave that as 2. You can customize the CIDR blocks if you want, which is the IP address space that's going to be assigned to each subnet. So with this, you can see this is no longer 16 as it was on the VPC CIDR range. This is a more specific number, so we get access to fewer IP addresses using this notation here. So with this setup, this number, the third placement here, if I can select it, yeah, so this 0 can be any number between 0 and 15, and then this number here can be any number between 0 and 255. So that adds up, if you do the math, that's 16 times 256, which is 4096. So those are the IP addresses that you get access to in this subnet. And then the other public subnet is just starts at 16, and then that one goes to 31 in this case. And then similarly for the 0, you get from 0 to 255. Anyways, it doesn't really matter, but these are just the IP CIDR blocks that you're going to be using for this subnet. And you can see the private ones are spaced out a little bit more. You can read up on kind of CIDR blocks and subnetting and everything. It's not really the topic of this video, but it's something that you may want to know about if you are going to be using VPCs a lot. All right, so you can see this thing is starting to come together here over on the right-hand side. If we scroll over a little bit, there's a couple concepts that are being talked about. So we have our public subnet here, and then it points to this route table. And that route table is going to be connected to an internet gateway, which is going to provide us with internet access. And then you also get 2 private subnet. So there's a private subnet right here and a private subnet right here. And they both kind of follow a similar path, except that they have different route tables. So these route tables are going to be assigned individually to each of these private subnets and only allow intra-network traffic, which we'll go and poke around with a little bit more later on. And then they also have access to a VPC endpoint for S3. And that's defined a little bit further down here. Yeah, so VPC endpoints. So this is a feature that makes it so that, for example, if you want to talk in your private subnet, if you want to talk to something like S3, you don't have to go out through the public internet. You can kind of have this back channel that you don't need to go out through the public internet, but you can access S3 through this private endpoint. And all of that network traffic stays within AWS's network. It doesn't go out to the internet and back into AWS. It all stays local. So there's a couple other services that I believe this is available for as well, like DynamoDB and some other popular ones. So this would be a great way to like save ingress and egress costs if you want. And there's no charge for using the S3 one, or I believe any VPC endpoints, but you may want to just double check that. There may be some kind of charge that I'm forgetting. Now, one setting that I neglected to mention is this concept called NAT gateways just above VPC endpoints in the console section here. So NAT gateways allow resources in private subnets to initiate outgoing calls to the public internet. So for example, if you have an EC2 instance that's placed in a private subnet, and maybe that requires periodic software updates and needs to connect to the public internet to do that, you would need to create a NAT gateway and place it in a public subnet. And then you would need to create a route so that anytime any piece of infrastructure in your private subnet tries to talk to the public internet, that is in turn routed through your NAT gateway, and your NAT gateway connects to the internet gateway. So that's how you would set that up if you want to use it. Keep in mind that it does cost money to use a NAT gateway, and it's not a small amount either. So just be sure you need it before you click either of these buttons above. Anyways, this is kind of the basic topology of our network here. So 2 public subnets in 2 availability zones and 2 private subnets as well in the same availability zones. 3 route tables, 1 for the public, 1 for each private subnet, an internet gateway, and a VPC endpoint for S3. So let's go ahead now and go to the bottom here and click on Create VPC. And you can see with this cool wizard thing, this is creating all the stuff for us. So like this is what you would have to do if you were doing this manually through the previous method. And it just takes a long time to set everything up. So let's see what this did. Okay, that's not what I wanted. We want to go back to your VPCs now. All right, so now we can see we have 2 VPCs available. And if you go into subnets, you're going to see all these different subnets. Some belong to our VPC, some belong to our default VPC. So a neat little trick that you can do is there's a filter that you can apply. So filter by VPC, and you can select not the default one, but the one we just created called My VPC. and click on that. And now the view is going to be scoped to the things that we just created. So let's just go and look at everything that we have here. So we have our normal VPC. Okay, that's the right CIDR block. It's got a route table here, a main route table. Let's click on this and see what kind of rules it has. So it has some routes. So this route is allowing for intra-network communication. This is the main route table. And if we look up top here, we can see we have some other route tables as well. We have one that's assigned to our public subnet and one that's assigned to both our private subnets independently. So if you click on this one should have a path to the internet. So if you go into routes now, you can see yes. So this one, whenever it tries to talk to the public internet, that's going to be routed through the internet gateway. And then if you look at the private subnets, this is only going to allow intra-network communication. So that's this entry here. And then this entry is for the VPC endpoint whenever someone tries to talk to S3. So if you click on this, you can see here, this is for S3, as you can see. All right, so this is looking pretty good. And so now if you wanted to do something like, I don't know, launch something like an EC2 instance into maybe a public subnet or a private subnet, we can do that really quick. So let's just go to EC2, into instances and launch instances. And yeah, call this whatever you want. And T2 micro, that's fine. We can put that one, sure. And now you can select your VPC here that you want to launch it in. It automatically selects your default VPC, but we want to change that here to the one that we just created. So my VPC. And then you can choose the subnet that you want to deploy it into. So either the public, so there's public 2, public 1. Let's say public 1 in this case. You probably want to auto assign a public IP address in this case so that you can access it externally unless you want to attach an ENI to it. But that's a topic for a different discussion. And then you can see here as well, if you want to have SSH access to this instance from the public internet, this rule that it's applying via security group is saying we're going to allow SSH on protocol TCP, which is port 22 for SSH. Source IP can be anywhere on the internet, or you can restrict this to be just your IP address. And then that's pretty much it for this instance. You can go ahead and launch it. And now this instance should be within our public subnet that we just created previously. And so, yeah, so there's our instance. It's currently booting up. I think if we click on this, we can see anything about the subnet. Yeah, so it belongs to the right VPC. And here it is in the public subnet of our VPC that we just created. So yeah, this is just a demonstration of how VPCs work, how to create your own and launch an instance into one. If you enjoyed this video, check out my other ones on AWS to the left and right. And thanks so much for watching. I'll see you next time.